Okay, this is problem number 13, page 346. This was chapter 6, section 3 we're working on. And we look here, just like problem 11, we have another differential equation. And so the first thing we do is we multiply by dx, and we get du is x secant squared of x dx. And we notice too on that differential equation, I should have pointed that out. But look right here, we have an initial condition, which we'll use at the end of the problem to figure out our constant. Okay, we've separated. We have all our x's on the side with the dx. We've got our du here by itself. So now that we've separated, we're ready to take the integral of both sides. So we'll take this integral. I'll take the right-hand integral. The left-hand integral is easy. That's just a u because, look, there was a 1 in there. So we get a u. And on the right side, we have a product. And we've done enough of these now at this point. I think you recognize, well, this is a product. Do I do it off the top of my head? Nope. Do I try u to u? Doesn't work. So it looks like integration by parts. We have our acronym LIPIT. Oops, that's an I. We have to make sure we didn't get fooled on this. So our first option is L. There are no logarithms. Doesn't work. Our second option is an inverse trig function, and that secant squared looks kind of inviting, but that's a regular trig function, so that's not it. So we really are down to our polynomial yet again. And when we're down to our polynomial, we know we can do tabular integration. Our first column is x. Our other column is secant squared. Coming down the left column, we know we're taking derivatives. Coming down the right column, we know we're taking integrals. So let's do this. The derivative of x is 1. The derivative of 1 is 0. Right side, the integral of the secant squared of x is the tangent of x. And then be careful with this. This is one, hopefully you just know off the top of your head. If not, you can derive it. The integral of tangent is the negative natural log of the absolute value of cosine. And again, if you forgot that, the integral of tangent of x dx, you could just quick remember tangent is sine x for cosine x, and do a quick little u to u substitution, letting u equal the cosine of x. And as soon as you take that du, oh look, you see a negative popping up. So it kind of explains where that negative comes from. Okay, back to our tabular integration here. We know the signs alternate. We've got a plus and a minus and a plus. Coming across right here, we start to see our answer form. And so we have u equals, I've got x times the tangent of x, so x tangent of x. For my next term, I notice I have two negatives, so it becomes a positive. I've got the natural log, write that a little neater, got the natural log of the absolute value of the cosine of x plus c. And now we come back right up here to our initial condition. Let's figure out what our constant is. For u, let's sub in a 1. For x, let's sub in a 0. So for u, I sub in a 1. X, I put in a 0, so I got 0 times the tangent of 0, which is 0 times 0, plus I've got the natural log of the absolute value of the cosine of 0 plus c. Okay, 1 equals, again, the 0 times tangent of 0 is 0. Let's be careful with this. I've got the natural log. The cosine of 0 is 1. Don't really need the absolute value anymore. And I know the natural log of 1 is actually 0. So I got 0 plus c. And 1 equals this. So I can see 1 is my constant. Once I've determined that, I want to make sure I write the final answer very clearly. So I'm going to write u equals, I had x tangent of x. Then we had plus the natural log of the absolute value of the cosine of x. And now we've just determined our constant, and our constant is 1. And for some reason, my smartboard has let out on me here, but we end that absolute value. We would put a plus 1 on the end of that, and that would complete this problem. Oops, see if this will right now. Sorry, had a little technical difficulty there. Now that really does complete the problem. X, tangent of x, plus natural log of the absolute value cosine of x, plus 1, giving us our final answer.